The bone consists of 10% of water, 30% of organic substance, and 60% of inorganic substance. The most important components of bone consist of calcium and phosphorus. Meanwhile, the not so less important components are magnesium, sodium, hydroxyl, carbonate, and fluoride. Metabolism of calcium and phosphor. The metabolism of calcium and phosphor is closely interdependent. Both are regulated by active metabolites of vitamin D, parathyroid hormone, and calcitonin. These hormones are metabolically active at bones, kidneys, and intestine. Bone is the reservoir of 99% of the total body calcium and 90% of the total body phosphorus. Only 1% of calcium is in the extracellular fluid. Only 50 milligrams of calcium is intracellular. This is extremely important, and it is mainly located in mitochondria. The maintenance of narrow normal range of total plasma calcium is vital. It is around 9 to 10.4 milligrams per 100 milliliter. Half is ionized, the other half is protein bound. Less critical is the maintenance of normal plasma phosphate in organic, approximately 3 milligrams per 100 milliliters and 5 milligrams per 100 milliliters in children. This is inversely correlated with age. Functions of calcium. It controls internal regulation of the function of all cells. Calmodulin and actin have prime functions in modulating the intracellular effects of calcium. Extracellular calcium ion concentration regulates synthetic and secretory functions of parathyroid gland and thyroid C cells. It controls adhesiveness between cells, and it controls the hardness and rigidity of bones and teeth through hydroxyapatite. It depends on the normal integrity of intestinal mucosa, normal gastric acidity, the presence of active metabolites of vitamin D, and the presence of bile salts and pancreatic enzymes. The calcium is excreted both in the urine and in the feces. Phosphate homeostasis. Dietary phosphate is also absorbed through the small intestine. This is achieved by diffusion and active transport, stimulated partly by active metabolites of vitamin D. The kidney plays a pivotal role in regulating the plasma phosphate. Actions of parathyroid hormone. It is stimulated by hypocalcemia. It inhibits renal tubular resorption of phosphate. This decreases plasma phosphate concentration. Actions of calcitonin. It is stimulated by hypercalcemia and inhibited by hypocalcemia. Actions of vitamin D metabolites. 1,25-dihydroxycalciferol is the most significant. It acts like steroid hormone. It increases renal tubular reabsorption of calcium and stimulation of synthesis of calcium-binding protein in intestinal mucosa cells. 1,25-dihydroxycalciferol and 24,25-dihydroxycalciferol are under feedback regulation. This increases with hypocalcemia, hypophosphatemia, and parathyroid hormone. The joints are classified as syndesmosis, synchondrosis, synostosis, symphysis, and synovial joints. In synovial joints, the two opposing surface is covered by hyaline articular cartilage and joined peripherally by fibrous tissue capsule, enclosing cavity that contains synovial fluid. These joints provide more movement than stability, for example, knee, hip, etc. The resilient articular cartilage acts as a cushion or shock absorber. However, once damaged, the regeneration is limited. The inevitable result is progressive degenerative arthritis. Embryonic development of synovial joints. The primitive joint plate is an articular disc of mesenchyme, the site of future synovial joints. It is surrounded by dense tissue. During the 7 to 8 week, the space filled with tissue fluid and form a single joint cavity. During the 6th week of embryonic life, active intrauterine movement is essential to the normal embryonic development of synovial joints. Anatomy and histology of synovial joints. The articular cartilage has the consistency of firm rubber and resilient. It consists of hyaline cartilage. Synovial membrane lines the entire joint cavity, except over the surface of articular cartilage and menisci. It has the ability to secrete and absorb. The medial and lateral menisci consist of fibrocartilage, mainly type 1 collagen fibers. The coefficient of friction of normal joints is 1/5 that two pieces of ice. This is made possible by mucin in the synovial fluid. Articular cartilage. Histological structure of articular cartilage. Hyaline cartilage is sparsely scattered chondrocytes and a vast matrix of intercellular substance. It is devoid of blood vessels, lymphatic vessels, and nerve fibers. It is arranged in 3 indistinct layers. The first one is superficial zone or limiting membrane. This is also called as lamina splendens. It consists of plethora of collagen fibers that are parallel to the surface and small oval cells. The second one is the middle zone. This consists of younger chondrocytes that somewhat are more active. Mitotic figures may be seen during childhood. The third one is the deep zone. This consists of collagen fibers that are vertical, and the chondrocytes are mature. During growing year, it functions as the growth cartilage. In adults, it is left as a tight mark. Joints and articular cartilage. The distinctive matrix, which is resilient gel, composed of tissue fluid for 70 to 80%, collagen for 10 to 15%, and proteoglycan for 10 to 15%. The cartilage is hydrophilic. The collagen of hyaline articular cartilage is type 2, while menisci consists of collagen type 1. It provides cartilage strength, especially in tension. The glue is the proteoglycans that bind the collagen fibers together. It provides resilience and elasticity to withstand intermittent shear and compressive force. It provides rigid subchondral bone, a protective shock absorber. Collagen and proteoglycan are synthesized by the chondrocytes. Chondrocytes respond to many stimuli: active or passive motion, growth factors, interleukins, and drugs. Bone and cartilage have similarities and differences. Both are derived from pluripotential mesenchymal stem cells. Both consist of cells lying in lacunae that embedded in intercellular matrix. They are reinforced by resilient collagen fibers. Bone versus cartilage. The bone is heavily calcified, so it has stone-like quality. It requires more oxygen, so it is highly vascularized. It consists of collagen type 1. The cartilage gets oxygen by long-range diffusion of synovial fluid into and out of the avascular matrix. It consists of collagen type 2, synovial membrane, structure and functions of the synovial membrane. It composed of two distinct layers. The inner one consists of syncytium, of few and loosely connected cells. There are two types of cells. Type A synoviocytes serve to clear the joint like macrophages. Type B synoviocytes. It synthesizes hyaluronate, a mucin that provides lubrication. Crystalloids, antibiotics, diffuse through synovial membrane via capillaries. Particulate matter is removed by the type A synoviocytes. Synovial fluid, a dialysate of plasma, plus glycoprotein and hyaluronic acid. It functions to nourish the articular cartilage and lubricates the joint surfaces. It has no fibrinogen, so it doesn't clot even when blood is mixed. Skeletal muscles. It constitutes 50% average of person's body weight. It requires almost 50% of body metabolism. It provides active movement of the articulated skeleton. It also provides maintenance of its posture. Isotonic contraction provides movement. Isometric contraction resists lengthening without allowing movement. Eccentric contraction allows lengthening while maintaining tension. Anatomy and histology of skeletal muscle. Each individual muscle cell or fiber is innervated by a single anterior horn cell of the spinal cord through a single axon. This is also called a single motor unit. The epimysium, it surrounds the entire muscle. The perimysium surrounds bundles of muscle fibers. The endomysium surrounds each individual muscle fiber. All of them act as harness. Each muscle fiber is thin, elongated, multinucleated cell. It has protoplasm or sarcoplasm. It contained by sarcolemma, in which the eccentrically placed nuclei placed. It contains small percentage of the nuclei represents satellite cells which may be important for muscle regeneration. Each sarcomere contains 3 million thick myofilaments, consists of myosin and actin. Sarcomere is a functional unit of muscle contraction. There are two main types of muscle fibers. The type 1 is slow oxidative for high repetition, high endurance. The type 2 is glycolytic for high power and speed. It has 4 subtypes. Biochemistry and physiology of muscle. The acetylcholine is a chemical mediator at neuromuscular junction. The energy of muscle is derived from ATP. The most important practical consideration of skeletal muscle is the ability to develop tension due to its contractile force and resistance of its connective tissue components to stretch. It has all or none low. The normal resting length of a given muscle is of great importance. Muscle can only become longer by adding more sarcomeres, primarily at the musculotendinous junction. Tendons and ligaments are made of collagen type 1 fibers. Both have remarkable tensile strength. They gain extremely firm attachment to bone at their sites of insertion. This is achieved by a continuation of their collagen fibers at avulsion injury. Stress deprivation, associated with prolonged immobilization, takes 6 to 12 months after motion has been resumed to regain their normal strength.